great question. So it would be so I have this analogy, right? Or this anecdote I tell that if I ask the average person on the street what a mathematician does, they really can't describe it. And I'm taking for granted, of course, that a mathematician does mathematics. And so ergo, it's actually really hard for people to describe what the mathematical act is. However, and I want to get to your question, it would be a mistake to think that what happens in K-12 is just has nothing to do with mathematics at all. That, of course, isn't true. So what do I think they get right? I think largely K-5 in a lot of schools, people get right. There is a way in which, like at that stage, you're learning the grammar of mathematics. You're learning what numbers are. You're learning how they interact with each other. You're memorizing facts, right? You're memorizing algorithms. I think all of that is important at that age, and it lays the foundation for things to come. So I think that is right. I would also say, although this is dwindling, the ninth grade geometry class still is a holdover of actual mathematics, right? So I went to actually a very good public district school growing up, and I remember ninth grade geometry. I remember doing the proofs. They weren't exactly the kind of proofs that I would advocate, but they were on their way, right? At least students were engaged in the acts of taking a conjecture and reasoning your way through it step by step and really presenting a proof. Because that, after all, that's kind of the end of the nature of mathematics, the writing of the proof, the rhetoric, the communication of the truth you've discovered. Again, I think some of that is dwindling in a lot of schools, but I do think there's some holdover in most schools in ninth grade of that reality. I also suspect that in most people's treatment of calculus, especially if calculus is something like an honors or an AP class, you're going to get a little bit more of that proof. I know when I taught calculus, we certainly were doing a lot of the applications, and of course I was teaching AP, so we were driven by that curriculum. But we paused on all the major theorems and offered proofs for them. So I think in some ways they're getting that right as well. And of course, look, they're getting the basics of the content right. I mean, their students are still studying numbers, they're still studying shapes, they're studying the ways that numbers interact with each other, the properties of shapes, what they are. I think the treatment of something like algebra is too much. I think we give too much of that and not nearly enough, say geometry or number theory. But even within algebra, I do think students should be able to understand how to graph a line. I think they should understand what Descartes brings to the table in connecting algebra and geometry by saying an equation has a picture and a picture has an equation, right? I mean, that's a really amazing thing that Descartes did. So I think they get a lot of that right. So I think the foundations are there. But if I'm in full disclosure, if I'm honest, I do think if we want to get this right, I think there's some substantial change to content that probably needs to happen.